Good afternoon, Saintsmen. We are going to start working on section 1.5, measuring angles. Right now, I am getting our chat set up so you guys can join in with any questions, and we will get begin right away. So here we go. First thing we have is a new geometric term for us to define together, which is an angle. Now, let's go back to a previous idea that we discussed in the course, and it's this. You guys can see I got my software working properly where it's giving me, it's straightening out my lines for me. We'll usually see if we can get this guy to work a little bit better. Um, what I have here is I have two rays. And with my two rays, they both share right here a common endpoint. This guy right here. Oops. You can see where my arm just stuck against my keyboard when I was writing here. Right here, this guy right here that I just pointed that arrow to, and that's its shared common point, endpoint. And when you have rays that do that, right here, we name this part of this figure the vertex, and where it shares a common endpoint. Moreover, as we have these two rays, right? What we refer to those two rays is these guys are the sides of our angle. So we have now defined what an angle is. So we have our parts, we have these rays that give us our sides. We have the shared common endpoint as the vertex, and I'm going to add a few other features here. I'm going to add a couple other points on here so we can actually name this guy and give you guys a little bit more notation. So ways that we name it. Every single one of these points, we're going to give a capital letter. And then what we do to name an angle is we do it by the vertex. Now, the way you do it is that the vertex has to appear in the middle when we list the 3 points. So I've got 3 ways for us to do it. Okay. Here are the first two. So we're going to have the angle. And what we do is we're going to write, that's our angle symbol, that little sideways symbol that you guys also on a keyboard, you'd find next to the M key. Where you hold shift and you can hit that. It looks like a less than sign. That's actually the less than sign, but this is kind of, the less than sign that kind of sits more on its side right here. Okay. This is going to be angle ABC. And we know that this is angle ABC because B is going to be the vertex. It's this, right? So that winds up being the middle one. So there's another way we could do this. It means the exact same thing. So we could say this is angle CBA. It's the other way for us to identify it. Now, mathematicians love shortcuts. We like to be concise. So another way that we can do this is we can actually give, if we write inside here a little number, I'm going to give the number 1. We can name it that way. It has to be given. We can't just arbitrarily assign it a number. It would be given that way in a diagram. But we don't have to write as much, and this is angle 1. Vertex is still a point, which is point B. I just used a term calling something interior with regard to the angle. So let's go ahead and take a look at what that means, right? So here's another angle that I have. In fact, I'm going to draw this one oriented a little bit differently, so we're not just looking at these things always the same way. Here we go. So I'm going to shade in interior in blue, and this is where we have what's going to be kind of inside. Now, even if I draw it, I'm going to show you guys another way. If we widen out the angle, what that's going to mean, and with regard to our figure. So, also, I hate typically writing stuff in red, but this is one time I'm going to differentiate. So I have a third color aside from my black writing, and then my blue writing, and then I'm going to kind of shade in. Oops, I just accidentally erased it. All this space outside here. This is what would be. Oops, my writing is so bad it's trying to correct it into becoming a shape. So yeah, this is exterior to the figure or to the angle. So interior versus exterior. So we kind of have some common ground when we are doing the work here. Um, three types of classifications of angles. And I'll give you guys some cues to how to remember these things. First one is this guy right here. Similar to the very first one that we had. And this is an angle measure that is less than 90 degrees. By definition, a less than 90-degree angle is called an acute angle. Now, one of the word associations we can use to remember that is that cute things are tiny. They're teeny tiny. This is the teeny tiny, it's the small angle, so this one is cute, right? Or not, and because it's cute, because it's teeny tiny, it is the acute angle. And then we're gonna have the wider angle, like this, which has an angle measure that's greater than 90 degrees. And this is the obtuse angle. And just remembering that if something is, for example, obese, it's fat. So this is the wide and fat angle. So it gives you a word association. Of course, last but not least, we have the angle measure that is equal to 90 degrees. And the way that we know is it has to be denoted with this little box right here. We can't just look at, and this is what I want to show you guys. When you guys see an angle written like this, do not make an automatic assumption that is a 90-degree angle. This may be an 89 or 91-degree angle. If it's 89 degrees, it's an acute angle. It's going to look like a 90-degree angle, but it's technically less than 90. So visually, we can't just make that assumption and say just because it looks like, because that's faulty logic. What we have to have is this little box in here at the vertex that's going to denote that this is indeed a right angle. All right. Give you guys another postulate. In my last previous existing video of this, I discussed this and called it the segment addition postulate, but we already did the segment addition. So we are going to now work with the angle addition postulate. So here's what we have. I have angle ABC. Okay. So I have these other points, right? I have ray BA, ray BC. There's the shared common endpoint B. And of course, there's angle ABC or CBA, same thing. And for the angle addition postulate, it's going to state the following. Oops, make that a little bit bigger so you guys can read my typing and we don't have to suffer through my writing. So this is the angle addition postulate that says that if we have C, which we do, I'm sorry, not C. If we have D, which we're going to draw here, and another ray, so now I have here three angles, Saintsman, and I hope you guys understand. Some of you guys are seeing, oh yeah, there's an angle and there's an angle. Well, there's more than that, right? What I have here is not just those, but then I have a third angle, which is ABC, which I was discussing before, but then I have angle ABD and DBC. So if I have that point, D, that's been constructed, and D is interior to angle ABC, then the sum of ABC, I'm sorry, ABD, goodness, I keep misspeaking, ABD plus angle DBC is going to be equal to angle ABC. So in other words, again, it's going to be that ABD, DBC is going to be equal to ABC, all because they share that vertex and, moreover, they share that side BD. So probably reminds you a little bit of the segment addition postulate, where there's that shared point on the line segment. Now, let's give it a little bit more here. This is angle 1 and 2. I'm going to name these guys. So moreover, what I'm saying here is that if I have angle 1 plus angle 2, that's going to be equal to angle ABC. All right. Now let's talk about congruence. The way we mark congruence, remember we did with the line segments, if we did with tick marks. If we do it with arc marks for angles. So I can do one, I can do two, but if I have the matching number of arc marks, it means that those angles are congruent. So what I just drew here is that I have angle one is going to be is going to be congruent to angle two, meaning that they have the same measurement. What that gives us then is it gives us an angle bisector. What it means then is that we have that ray BD, which is the angle bisector and what that means is that it has split the angle ABC into two equal parts. Okay, that's what this term bisector means. All right, and we're gonna come across that as we continue to do these problems. So I have now. Let's do some problems. I've got 3 problems for us to work on. First one is I'm gonna make a triangle here. No, I don't like that. There we go. I have triangle D, E, F, and then I'm gonna have some arc marks in it. Now, which 2 of these angles are congruent? Can you guys see? I hope that you see that 2 of them have been marked congruent. So what it's now asking is that if we have angle DEF and it's equal to 40 degrees, then what is the measure of DFE? And this should be pretty straightforward, is that if DEF and DFE both have been marked with the double arc mark, meaning that they are congruent. So if DEF is 40 degrees, then DFE is equal to 40 degrees. And the little degree symbol is that little circle to the upper right of when you're finished writing the number. Okay. Okay. Just a second. Just trying to get these examples to line up. Next example. I'm gonna have A. This is gonna be a B. This is gonna be a C, and then on my vertex is gonna be point V. All right. So here's my problem. If, I'm gonna actually write this out because this is gonna be a little bit easier with some of the notation that we're gonna do. If angle AVC is equal to 58 degrees, and we have VB, which is a ray, is the angle bisector, then the question becomes then what is the measurement of that AVB is going to have? So what is going to be equal to? So few things here. Let's go ahead and mark our diagram. Okay, this is not given to us. But if we know that AVB, or sorry, AVC, this entire angle here has been bisected through this. So what that's going to leave is 2 resulting congruent angles, right? AVB and BVC. Now, if we know that the entire thing is equal to 58, then it means that if it's been bisected, it's two equal parts. In other words, we're going to just divide by 2. We're going to take it in half. So that just means that angle AVC is going to be equal to 58 divided by 2, which is 29 degrees. Straightforward. Last but not least, in terms of our examples, this one's it's pretty fun here. Last one. Right. Again, do not make assumptions about things being congruent necessarily. So, we have P, Q, R, and S. And then we actually have a few other things to write in that we have. Angle PQS is equal to 7x minus 5 degrees. And we have angle SQR is equal to 9x plus 11 degrees. And then what we're being given here is that this larger obtuse angle, angle PQR, that measurement is equal to 102 degrees, okay? When you guys have that says measure, it's the measurement means that we don't actually have to put the degree symbol up in the top right corner, okay? If we are without that, then we need the degree symbol. So that's two notation things you're going to see moving forward. What we're going to do is we are going to be given the instructions that we are going to find the measure of angle PQS and the measure of angle SQR. So through angle addition, we'll be able to write the angle addition statement. This is mandatory right here. And that is going to be that we have angle PQS plus angle SQR is going to be equal to the larger angle right here, right? Something that we did earlier. Angle PQR. All right, just a little reminder there for you guys. This is mandatory. I have to have this for me to give you full credit for these problems as we move forward. And now we just are going to substitute. We know that PQS, according to the diagram, is equal to 7x minus 5 degrees, right? Plus SQR, which is equal to 9x plus 11 degrees. And then PQR, we're given up above, is equal to 102 degrees. Since we're working all in degrees, all these are just going to be, we don't have to write that down. And we're going to solve for x. Now, once we have x, that doesn't mean that we have found our solution. It means then we have to utilize that information to find PQS and find SQR, okay? So 7x minus 5 plus 9x plus 11. We're going to combine our terms, right? Our 7x and our 9x is going to give us 16x. Our negative 5 plus 11 is going to give us 6, and that's equal to 102. I'm going to subtract 6 from both sides algebraically to cancel out. So I have 16x is equal to 102 minus 6. Verify in your calculator if you don't want to make sure your arithmetic isn't messed up and you don't lose any points, okay? And then probably don't know your 16 times tables, no judgment about that. The 16s are going to factor out, okay, when I divide, and I do 90, because I can divide both sides by 16, and 96 divided by 16 is equal to 6. So kind of have an element to get our solution. Now we have to take that information and plug it back in. So remember, we have angle PQS, which we had equal to 7x minus 5, or 7 times 6 minus 5. 7 times 6 is 42, minus 5 is 37, and that's 37 degrees. And then we have, last but not least, angle SQR. Oops. Man, this autocorrect feature is really correcting things. SQR is going to be equal to 9 times 6 plus 11. 9 times 6 is 54. 54 plus 11 is 65 degrees. And there you have it, gentlemen. I wish you luck, and we'll tackle the assignment 1.5 in class. Thank you.